A blockchain is a shared database that no single user can control. Blockchains are decentralized, meaning they're distributed across many nodes and users, so it's hard to break one large chain into parts and gain access to the data. A key concept in blockchains is the consensus algorithm, an agreement between nodes that changes depending on the time of day or when transactions occur. This consensus algorithm prevents any node from adding false information to the database. Bitcoin is a peer-to-peer payment system that uses cryptography to keep transactions secure. Transactions are public and verified through a process called mining. The mining process ensures that no one can copy Bitcoin transactions from one node to another, since multiple nodes in the network verify each transaction before it's added to the database. Traditional databases are more centralized, meaning users must rely on a central source to confirm the transactions. This can make it easier for one actor to corrupt the data in the database. For example, as a blockchain like Bitcoin is used by more people, and transactions take place, it will evolve to become more decentralized. Blockchain is a distributed ledger that records all transactions within a system from one party to another so that neither can forge the other without going against the entire network. Immutability and data management. A blockchain is like a digital ledger that maintains a growing list of records, called blocks, linked and secured using cryptography. Each block typically contains cryptographic hashes of the previous block, timestamps, transactions, and data. This arrangement allows users to use the blockchain as a database. In other words, it simplifies processes like peer-to-peer payment systems by allowing users to transfer value directly over the internet without relying on third parties such as banks or payment processors to verify the exchange. Blockchain and databases use their data in fundamentally different ways. After being saved and managed, data in a blockchain becomes immutable and cannot be changed. It indicates that the data has not been altered or replaced, not possible to change the data. On the other hand, storing, changing, or recovering the data in a conventional database is possible. At the most fundamental level, conventional databases use the CRUD model to ensure the correct operation of applications. Because of this, data can easily be modified to reflect new values to your requirements or preferences, should those become necessary. Because of this, data stored in a conventional database cannot be immutable. Therefore, data could be hacked either by administrators or by third parties. Transparency. As a result of the architecture of blockchain, all information regarding the system can be easily accessed since users can access their records via public and private keys. Unlike conventional databases, where data is typically stored with some restricted access level, blockchain systems provide complete transparency regarding the records that are being stored. This means anyone can view all pertinent information regarding transactions on a single chain. This transparency allows users to access information about their transaction history and confirm the legitimacy of each entry before executing them. Speed and performance. As a result of the architecture, the speed at which blockchain applications can be deployed is much faster than that of conventional systems. In addition, complexity and management costs are significantly lower than existing database technology. Conventional systems are typically incredibly complex and require a substantial amount of maintenance. Moreover, traditional databases usually require advanced software to access their data and operate correctly. However, blockchain applications lack these problems as they run on an open-source distributed ledger framework that allows for transparency and controls not possible in traditional methods. Heterogeneity. By nature, blockchain applications offer more diverse possibilities and opportunities regarding data management and the scope of data available to users. With this range, not only are all users treated equally, but no user is excluded from participating in the transaction. Unlike conventional databases, where there is limited participation from smaller operations, blockchain applications allow for a wider range of participants to participate in the ecosystem by providing them with access to the records that are being managed. Control. Because blockchain is decentralized and distributed, it gives users significant control over their data. In a conventional system, various third parties can alter data or even delete it entirely. However, in a peer-to-peer ecosystem, this is not possible. This is mostly because information and transactions are stored in blocks coded, making deletions or alterations to their records impossible. In addition, blockchain is a distributed system that uses massive computational power and resources. Thus, it would not be economically feasible for one entity to compromise or alter information in the network, since doing so would require the undoing of all the computations done by thousands, if not millions, of computers. For instance, for someone to alter data from a block in a blockchain, they would have to redo all the computations that have been applied to every block that follows throughout the entire chain. Conclusion. In conclusion, blockchain technology has become an omnipresent phenomenon that has contributed significantly to our daily lives. The use of blockchain has transcended the financial market to the core level. The technology is moving toward all industries to gain sizable adoption. Currently, many industries are looking at using this technology in various ways. Some companies want to ensure their data is more transparent and accessible for multiple users. Other companies want to ensure privacy and control of their data. Blockchain technology will significantly grow in popularity and usage in the next few years. This is rooted in the fact that this technology has all the characteristics of disruptive technology, which refers to a product or application that not only meets their needs, but also increases productivity for users by solving a problem for them.